Perhaps it was obvious, but we are going to need to know how to trace code that uses shared pointers. And we're going to need to understand exactly when, over the course of the program, the destructors for objects that have been allocated using smart pointers get called. And so, as with all tracing examples at this point in the course, I can't fit everything onto one screen. So what I've done is I've put all of the boilerplate on this screen, and we're not going to come back to this screen, but you can take a look now or take a look at the posted version. I've got my slimmed down fruit class. It's a little bit more slimmed down than it was in earlier examples because I'm not printing the word fruit, because I'm only going to have this one class to work with, and to save myself a bit of writing, I'm not printing out the name fruit. And then, because I'm going to work with a lot of variables of type shared pointer to fruit, and this type name is a bit bulky, I'm going to define my own type name to use instead. So whenever I write fruit pointer, I actually mean this whole thing. Not only is this great for tracing because it saves screen space, but also it is a good idea, I think, in practice. I often do this in code where I'm using shared pointers because this type name is a bit bulky, and also it's not as obvious, I guess, to somebody glancing at it what you're really looking at. Something like fruit star, I guess by now we sort of know what to do with that. This name isn't as immediately recognizable. So I make my own type, fruit pointer. It might clean the notation up a little bit. So here's my program. And I have to be very careful how I draw stuff because I have to make sure I've got enough space for everything. And so I'm going to start with a scoping box for main. I'm going to draw my output in 2 columns like I've had to do in previous videos. And I'm going to do a few simplifications. Hopefully, I mean, it's clear by now over all the last few tracing examples we've done that the extremely rigorous diagramming style of CSC 111 has to get unraveled a little bit in a course like this because we're talking about higher level things. And also because we've developed enough dexterity that we don't need to micromanage as much. So one thing I'm going to do here is observe that in main, every single variable has type fruit pointer. So a shared pointer to a fruit object. Because every variable has the same type, I'm not going to bother writing the type of each variable on top of its box in main. And again, you can simplify whatever you want, so it's up to you whether you make that simplification yourself. I feel like I can be responsible with that simplification because I don't think, as long as I know that's the type, I don't need to have it written down over and over again. Similarly, I'm going to keep making objects of type fruit. And I know that a fruit object, technically speaking, so if I have a fruit object, it has a member called name that is a string. And that might be the word pear. On the other hand, because I know that that's all just placeholder stuff, I need to have a member in the class for the sake of the class being relevant to anything, I'm going to draw my fruit objects like this, just pair, with the understanding that I'm not working with strings anywhere in this program, so if I see a name in a box, I'm going to assume that's a fruit object. I'm not even going to bother with the type. Now, whether you do this simplification is your business. There are examples you could work with where there are more classes than just fruit present, in which case you probably do want to use the class name. But it's a question when you look at the example, what simplifications can I make that I don't need to be too worried about? Where am I not taking any unnecessary risks? So when I draw a fruit object, I'm just going to draw it looking sort of like this, and that's it. And I can still differentiate that from other things on my diagram. The key is to have a diagramming style that doesn't, get too much in your way. Diagrams are great for keeping your thoughts in order, but there's only a certain amount of order that you need in each context, depending on what your focus is for that tracing example. Okay, so I'm going to start running on line number 6. On line 6, I'm going to create a new variable in main. Its name is going to be Q. It's going to be the result of calling the makeShared function, giving it the name for the fruit object lime. There it is. I'm going to tag this object because I'm using a shared pointer. I'm going to tag it with its reference count. I'm just going to clean up the letter L there. Its reference count is 1. The makeShared function gives me a new object with reference count 1 and then sends me back the single pointer that exists to that object. There it is. And then on line number, actually I missed one thing. When the makeShared function creates the object, it calls the constructor. Because it's not all on the same screen, I guess I missed that. I better make sure I don't forget that again. So I caught that one in time. So I print out constructor, lime. And just to emphasize that, the fruit class does basically nothing. When you call the constructor, it prints that it's the constructor. When you call the destructor, it prints that it's the destructor. So I print out the constructor for lime. On line number 7, I then make a new variable called R, which is going to be initialized to contain, it's going to be a fruit object containing the name pear. Formally, the constructor gets called about here. So before the makeShared function is done, that's where the constructor actually gets called. So constructor for pear. And it also gets a reference count of 1. And then R points to that. All right, so we now have two objects floating around in space outside of a scope, and we now have 2 pointers inside of main, each of them pointing to one of those 2 objects. Now we get to line number 8, and we are ready to generate some output from main directly. We print out main1. On line 9, you've got one of those famous if statements we're so used to seeing in tracing examples, which is basically saying there's going to be some scoping shenanigans on the horizon. So there's our if statement scope. Hopefully that box is big enough. And then on line 10, we create another fruit object. This one's going to be called grapefruit. So I call make shared. It creates this object named grapefruit. There we go. It tags it with a reference count of 1, and the single pointer that's created to it is returned to main and is stored in the scope of the if statement in this variable called s. And then line number 11, and then I do remember to call the constructor for grapefruit. So you might look at this and say, wow, you're forgetting a lot, Bill. It was really fair to trace code like this. So the problem with tracing examples is that there's always that one thing that catches you. When you're tracing code, there's always one thing you take for granted and you forget. Because I'm so obsessed with drawing these boxes, I have so much fun with that, I forget the constructor. What you can do in cases like that, because often the thing you're making a mistake with, the thing you're forgetting, is something you can identify in the code. What you can do in cases like that is go through and tag any future instances. So I just noticed 3 times with the make shared function, I almost forgot to run the constructor at all. Because I can foresee that could be a problem in the future, because if I miss one of them, the whole program might break. If I foresee that might be a problem, I could try and make some note to myself anywhere else in the program where it might happen. So for example, here I could write something like constructor. And up here I could write constructor. I could just literally write on the code to try and remind myself that there's something I keep forgetting to do. I could even put a little red mark here. So if I get to these future lines, I know that there's something I need to check into. Maybe the constructor doesn't get called there, but just in case it does, I notice those lines are places it might, so I can tag them as a way of not forgetting next time. Anyway, I did call the grapefruit constructor, fortunately. I get to line number 11 and I print main2. And then on line 12, Q equals R. Okay, let's just think about that from the point of view of the first law of assignment statements. So, okay, what is the value of R? R is an arrow pointing to pair. Okay, so I'm going to set Q, which is the left-hand side of the assignment, to be an arrow pointing at pair. But I know whenever I modify a smart pointer, the reference count gets adjusted. So because Q will no longer point at lime, I'm going to adjust the reference count to be 0. And that means that, so I'm going to just detach the arrow. That means that lime has to be destroyed. And that means that I should see the destructor for lime get called here. And then I just erase this because it's gone. And then I redirect Q to point at the same thing R points to, which is the object called pair. And I update the reference count to be 2 because now 2 things are pointing at it. Okay, that's the end of line number 12. And then line number 13, I print out main3. There it is. And then I'm out of the if statement. So what's interesting here is, as we can see, the if statement ended and I didn't really do anything useful in there, but be very careful. Remember that the object S, we're at this part of the course now where our objects have destructors. The object S is a smart pointer. It's not as simple here as just erasing the scope. Whenever a smart pointer gets modified or destroyed, I need to update the reference count. So on line 14, when the scope for the if statement ends, before I go erasing the scope, I have to destruct the object S. And the destructor for a smart pointer decrements the reference count of what it points to. So we'll detach the arrow. Now 0 things point to grapefruit, and so the smart pointer automatically destroys the object. And so we get destructor for grapefruit. Okay, so I can erase the object. And now the destructor, we can interpret that as being the end of the destructor for our smart pointer. So when the smart pointer is destroyed, it decrements the reference count and acts accordingly. I can now erase the nested scope. Which hopefully frees up some space to make more variables in main. There we go. And then I get to line 15, which says I want to make a new object. Its name is going to be T. There, I'll just put it, I guess, here. And it's going to be the result of calling the make shared function to create an object with the name lemon. So there it is. I draw the box for it. I tag it to have 1 reference. I remember, because I've made a note to myself, to call the constructor. So there's the constructor for lemon. And then I assign the arrow to T. Okay, so it gets sent back. I can now erase the little note I made to myself here. Okay, so I'm done line number 15. I've constructed the object called lemon. I've called the constructor. I've set the reference count, and I've assigned the pointer. Line 16, I set T to point to nothing. Okay, so I'm modifying a smart pointer. So I first adjust the reference count for what it used to point to. Now lemon has nothing pointing to it, so I destroy it. So destructor for lemon. And then I erase the object. And then I set t to point to nothing. So t is going to be a null pointer. I usually draw those like this. Okay, line 17. Set t to point to the same thing q points at. Okay, so normally when I reassign a smart pointer, I have to make sure that I decrement the reference count for what it currently points to. But on line 17, t doesn't point to anything right now. So I don't have to bother with decrementing any reference count. So I set t to point to the same thing q points to. So t is now going to point to pair. And that means I have to increment the reference count for pair. Now it's 3. There are 3 different pointers pointing to it. And then I print out main 4. All right. Okay, so now I make a new pointer called, I have to be strategic about where I do this. On line number 22, oh, whoops, actually, sorry, I actually missed an entire line number 18. So when you notice you miss a line, you have to rewind the best you can. I only hit a line of output. I haven't done anything new since then. So I think if I just leave the line of output there, we'll see if any more output is needed between line 17 and 18. On line 18, I was supposed to set t to be a null pointer again. So first, t is about to be changed, so I decrement the reference count for what it used to point to. Now pair is going to be the reference count 2 again, and now t points to null again. And I look at that and say, okay, no more output was generated, so the fact that I fell behind isn't a big deal. It still says main 4 next. Everything else is still salvageable. Okay, so now after main 4, on line 22, I make a new pointer called v. And I set v to be the result of this function makeThing. Okay, but I haven't called the function yet, so I'm going to call the function and then come back. I've got to be very careful where I call the function, so I'm going to put the box for the function up here. There it is. The function takes no arguments, which means I'm all ready to go. The very first thing the function does is create something called y. Y has type auto, but I should know that the makeShared function returns a shared pointer to a fruit, or in our context, fruit PTR. Here I'm going to write that in because auto may not make that obvious to me. So what is y? Well, I tell the makeShared function I would like a new object with the name raspberry. There it is. I spell raspberry correctly. I put it in a box. I give it its initial reference count of 1. And then I initialize y to point to that. All right. And then, let's see. So I have to call the raspberry constructor. I guess as I said, theoretically, the raspberry constructor gets called before I actually finish drawing the box for raspberry. But as long as I get the output in the right order, the way you abstract that is sort of your business. Okay, so I call the constructor for raspberry. Now the makeThing function ends, and it returns the pointer. The way we should contextualize this is that the return value gets copied in before the scope is fully gone. So first, I set the return value in main, so v is now going to point to raspberry, and so I increment the reference count. And then once the return value has been set back, then I destroy the scope for the function. When I destroy the smart pointer y, I decrement the reference count. Now it is 1. But of course, it's not 0, so no further destruction is needed. So I just erase this, and now we're back to main. And I guess I can erase the note I made to myself earlier here. All right, so back in main, v now points to the object that has the name raspberry. I now print, and I guess nothing else needs to happen. And so now I print out main 5, and I've got to try and cram in 2 more lines of output here. Now main ends. And so I destroy all of the variables in main. I call the destructors for everything physically inside of main. And we have to keep in mind that there's an order this is done. I always destroy variables in the opposite order that they were created. So Q was created first, then R, then T, and then V. So V gets destroyed first. The destructor for V decrements the reference count, and now the reference count is going to be 0. As soon as the reference count hits 0, so I detach V from it, and then I call the destructor for raspberry. Because as soon as the reference count hits 0, I must destroy the associated object. There it is. I'll just erase it. And now V has been destroyed. I call the destructor for T, but nothing needs to happen because T points to nothing. So I get rid of it. I call the destructor for R. So when I destroy a smart pointer, I decrement the reference count. Okay, it's 1, but 1 is still fine. So I just erase it and I destroy R. And finally, I destroy Q. When I destroy a smart pointer, I decrement the reference count. If the reference count hits 0, then I destroy the object. And so at the very bottom here, I write in, with what's left of my legibility for today, destructor for pair. All right. And then I just erase this. And then finally, Q can be destroyed, and now the scope of main is now over. But in any case, I have now finished all the useful code here, so I don't have to bother erasing anything further. I have this rather cumbersome amount of output. And we saw over time, the key outcome of a question like this, of course, is keeping track of those reference counts. Knowing when to increase them, knowing when to decrease them. Knowing that when you decrease them, if they ever hit 0, that is when the destructor has to be called. I would encourage that you take a look at the posted version of this code, because there are a couple of other variants of this that are worth trying. So one example would be, what if I got rid of these 2 lines here? The object that originally, so the object called lemon, the one that T originally pointed to, will still have to be destroyed. And it's worth noting what happens in that case. The output may not change much, but it's worth being able to trace your way through that. Similarly, it's worth considering what would happen if I replaced this with S equals R. Or if I replaced it with R equals S. Because both of those variants would, I think, dramatically change the ultimate output that you get when the object referred to by S gets destroyed. Because the smart pointers do give us a large amount of the freedom that we get with new and delete. Not all of it. Because unlike with new and delete, we can't be capricious and forget to destroy objects. But we can still manipulate the lifespans of the underlying objects in ways that don't necessarily conform to the rules of scope. Because we can, by reassigning pointers, decide when the reference count hits 0 and when the object gets destroyed. And that's worth practicing in tracing questions.